So for today's second session, what we're going to be looking at is long versus wide data. And these are two different sort of shapes to data. And we will look at the differences between them and sort of maybe which situations call for which shape. And then the post-session workbooks will be taking a look in R how you can sort of transition your data between these different formats. So the learning outcomes for this session would be to be able to explain what the difference between long and wide data is, and then also consider and identify situations in which you might prefer long data over wide data, but then also the reverse. When would you might prefer your data to be wide over long? So we often describe a data set as being a rectangle of data. That's likely a phrase you will have heard, but there's sort of a little bit more to that in that there's two ways we could maybe orientate this rectangle, if you were. And which one of these you might use could depend on what you're actually hoping to do with that data and what that data means, or even how it was collected. And even to an extent, personal preference can come into play. You might find that doing certain analysis is easier, or certain plotting is easier when your data is one format over the other. As I say, how you collect your data may lend itself into a particular shape as well. And this is something I might show you with ODK and their data downloads, particularly when it comes to repeat groups. So let's have a look at what we actually mean by these different shapes. So wide data is probably a format you are quite familiar with. It's generally, I would say, it's probably the default for some things. And so every row is one observation and every column is a single measure. It's essentially the default shape for conducting any sort of data analysis. And it's probably what you would most likely to see. It's certainly easier. It's easy for us as people to interpret. It's quite simple to follow and everything's quite neat and tidy, because all of your variables have been nicely separated and everything is kind of all in one. And the alternative is long data. And sort of generally what this means is that kind of squishes it a bit. It sort of transforms the data so that rather than, in this example, we don't have one row per observation, but instead we have one row per measure within an observation. So what you see is that, whereas here we have our first plot, our second plot, our third plot, and a fourth plot, and then we've got separate variables for height, flowers, and pests. What we now have here is height, flowers, and pests have become rows in themselves, and then we actually have variables that are, one is measure and one is value. So in this example, rather than having one row per plot, we've now got three. Now I understand that immediately this doesn't seem to make sense, or at least its use may not be immediately clear. And you would see that this definitely doesn't seem useful potentially for analysis, and you can argue goes against the rules of tidy data. But I hope that through this session that the usefulness of this sort of data formats will become clear. I'm going to start showing off a couple of examples that I came up with. So I think there's sort of three in particular that I sort of noticed on my sort of use of data is that sort of longitudinal repeated measures data. So this is cases where you're taking different measurements over time. So this could be that you have the same sort of survey set up and you go to the same people maybe a year apart. So you have a set of data that's at one point and a set of data that's at another. And if you maybe want to merge these so you can make comparisons within the same data set, you could either have that, so you have basically to the left is all of your 2019 data and to the right is all your 2021 data. Well, sorry. Sorry about that. So the alternative to having it wide like that would be to have it long, where you have sort of 2 rows for each person, and 1 row is their basically baseline, or 1 is their midline. That's one way I've used it a lot before. So I think that's quite similar. So similar to the example that sorry. So someone provided in the chat, is that while they're about the same person, you instead have 1 row per sort of time point within that person, essentially. And again, this comes on to, I think this is essentially exactly what that comment was, is that having data at different levels of a hierarchy. So again, to go back to an example of farmers and their plots, you could have, now you could keep that data about the plots also at the farmer level, where you have the farmer information, and then you have a group of columns that's like all the data about plot 1, and then a group of columns that's all about the data of plot 2, and then plot 3, etc., etc. But then that makes comparisons a bit more complicated. So it would be much better to keep that data at long format, where you have a row for each individual plot, rather than a column that's the size of plot 1 and the column that's the size of plot 2. It makes it a bit more difficult to compare, and then say then you wanted to create an average of plot size, you've got to do that across X amount of columns when you can just do it simply across the one. And a little extra one that I noticed, sort of even when it comes just into your analysis, you might want to do a quick little transition for your data from wide to long, is sometimes even plotting can be useful as well. So if we go back to this one, for example, say I wanted to plot this information on one graph using different lines. The code to make a line plot, say, of height and pests, that might not be the best example, but it would be much more complicated to do it from this, as I would need to add code to, okay, now make the line for heights, now make the line for pests. Whereas with this one, I can just say, make some lines for measure, but do a different line for each of these. That would, in terms of the code itself, that would be much simpler to write. So that's sort of a less sort of maybe input. I don't know what the word I'm looking for there is, but a less a lower priority problem that you might come across that requires switching between these 2 data formats. Whereas these first 2, that would play a big role in how you're analyzing your data and how big your data is as well. So just to sort of go onto these a little bit more into a bit more depth, is that if we were doing some longitudinal and repeated measures data collection, if I were to use a wide data format for this, basically each row be the same plant, the same person, the same plot, the same time points. So this would be what it is up the top. So I have my person A, and I've recorded their heights at 3 different time points. I have person B, I've recorded their height at different time points. And sort of this might be useful if I just wanted to take measures at these different sort of time points. So I could get the mean of people at height 1 and the mean of people at time 2 and time 3. But then I'm doing that separately. You know, I'm doing bits of different code to get each of those means. So as I said, this might be a bit cumbersome when it comes to analysis, maybe. And some of them might make your analysis a bit smoother, and the data management also a bit more code heavy. Less code heavy. Is that perhaps pushing it like this? Is that putting that in long format would be that each time point is its own row instead. So you still have this identifier for person, but now you've split their time point into rows. So coming back to plotting, for example, if I tried plotting this line, that would be a bit more difficult because the measures are kept across different columns. So I'd be needing to try and plot each individual time point somewhat manually. Whereas if I have it in long, then I can quite easily say, you know, put time on X, put height on Y. It's in a format that is much more suitable to plotting. And in a way, this also comes back to the issue of messy data, is that time point is a sort of unit of observation. So, and of course, generally a unit of observation, we would consider that to be what should perhaps be defining our rows. And therefore, long format is doing that. We have a 1 row per time point per person. That's sort of our unit. Whereas in wide format, while we're keeping 1 row per person, we now have these 3 different units within that row because we're storing all of the same information but in different columns, if you see. So we have height, but we stored it across 3 different columns because we've got columns for different time points. And then in a very similar fashion is that what we have with hierarchical data. So it's a very similar issue. It's just whereas rather than having these repeated measures in these same variables, what we have is data that's at different sort of levels of a hierarchy. So this is where you have plants within a plot within farmers, and you have you can store information at one of these levels and say put those information from a lower level into wide across that higher unit. So in this example, again, we've gone with height, and we have heights recorded for plant 1 and plant 2 on this plot. So when we're having this in wide format, we have at this higher level, wide format that is that we have these 1 row per plot. So we have plot, we have what fertilizer is used on that plot, and then we've put separate columns for the higher plant 1 and the higher plant 2. So this would be storing that. So we level in wide data at the plot level. Perhaps what would be better though is storing that information at the plant level, and therefore we would be transitioning into long format. So this is putting it at the plant level, but you're also keeping that plot level data. It just becomes repeated. So fertilizer is kept as a column. So this sort of brings me on to sort of an important thing about ODK and its repeat groups. So if we had collected this data in ODK, basically what we would have done is like ask about, okay, so about plot one, how many plants are you growing? In this example, both are growing 2, but that could be more, it could be less. So then we would have repeated questions about each of those plants on the plot. And this would create a repeat group. And just to, so, so there's kind of some different ways in which ODK might give you this repeat data. I think this is not so much on Kobo toolbox I've noticed, is that now it does quite seem to force you with repeat groups into being long. It used to, I think, allow for wide, but it doesn't seem to anymore. But basically, so these downloads actually come from ONA, which is another system you can use for ODK. Is that if we sort of scroll along and find some information from a repeat group, is that, okay, so here's some examples, is that so these information here across these columns is coming from a repeat group. And so you'll notice you have this one in here, and that's sort of denoting what number within that repeat group it is. It's our sort of unit identifier for these columns, is that, okay, this is plot 1. And if I scroll along, you'll eventually see, where is it? Oh, that one, maybe those weren't. Hang on, sorry. Here we go. Sorry, here's some examples. You have these fertilizer details, and these are coming from a repeat group, and you have these sets of columns, and these are all doing it about the first fertilizer. And then scroll along, we eventually get to, okay, now we have the second fertilizer, and here's that same information. So the source of input, the name of input, the quantity applied, the date of application. You're seeing these same variables repeated, but that first set is about the first fertilizer, then the second, and now we're on to the third, the fourth, and then that's sort of where it stops. So this is keeping that fertilizer level data in wide format. And that might be a bit difficult to analyze sometimes, especially as, if I can see an example, is that you can see for this person that their first fertilizer was cow urine. So here's all their information about cow urine, but then the one below them, their first one was compost. And then over here, you've got them using compost. So if you wanted to compare that information on compost, then, you know, in wide format, you've got information about compost here, and you've got that same information about compost, but it's over here. So this is sort of an issue with wide data when you have these data at different hierarchies as well, is that quite often, especially from raw data, it's going by sort of what order that was inputted and not grouping it together. It's not grouping those columns based on what those columns specifically refer to sometimes. And that might not always be an issue, say if you're doing household member, but for something like this where, say, the repeat groups were defined by sort of things that came from a multiple selection, which is what these were here, is that you get the columns for the first thing they picked, and then the columns for the second thing they picked. And not the columns for compost and the columns for cow urine. Like, that might be slightly more easy to analyze, but it's probably still not the best way to do it. Alternatively, though, is that what we can do is get them from long formats. Is that what we'll do instead is that the ONA, will sort of keep information from the different hierarchies apart. So instead, here is our sort of main level of unit, which is the farm. So there is all the farm level information. And then instead for fertilizer, rather than putting it with all this farmer level information, what it's done is store that at its original level, so that we have a separate table, which is, so I think here's that first one again, that one that's using urine and compost, and they're putting those fertilizers as rows to define as instead. So this is storing that fertilizer data in long format rather than wide, but in a separate table. So this is bringing us on to relational data, which is something we'll be looking at a lot more in depth on Wednesday's sessions. But generally the point is with relational data is that you have data about potentially different units, and these are stored in their own separate data sets at the level that they represent, but through sort of keys and key variables, they will be able to link together. So in this example, what you have is, so this index is defining each row within the data, and then you have this parent index, which is to link back to the kind of row within this data table. So in terms of how you get, so ONA is a similar sort of system to Kobo, although it's not, I believe it's not free in the same way that Kobo is. But just to demonstrate the sort of wide versus long thing that it does versus what Kobo does, because I think Kobo seems to now prioritize that second way of keeping repeat groups in separate data tables in long format. It doesn't seem to have an option for that wide data format anymore. I believe it used to, but they did a bit of research and I couldn't seem to find that anymore. So if I prepare a data export, if I were to use CSV as a data file type, what we would get is these repeat groups being pushed all into one level in wide format, because the CSV is only the one data table. Alternatively, Excel is what we would produce with that long data one, where it keeps these information from the repeat groups in separate sheets. And I presume Google Sheets does that as well. And what CSV zip would do, it would store these different long data tables as separate CSVs, just in a zip file. So yeah, this all comes from the repeat groups. You know, you have groups of questions that are repeated over some unit, and often in our experience, this is across plots or members of a household. And as we've seen there with ODK, is that we can store this information out wide or at long, but generally long is probably better. So yeah, under wide, each would have their own column. So here's the information for first person, here's the information for second. But generally, when it comes to analyzing and even viewing the data, it looks a bit more tidy having it like that in long format rather than wide. And there's just a little bit more on what I've shown you regarding ONA, is that CSV will export to wide, but XLS with Excel, what that will do is put it into long separate tables. So, and then just to conclude that so wide data, what that does is one row per observation and one column per variable, and long data is sort of one row per variable or unit within an observation or another unit. So one household member within a household. It's rather than one household, it's coming down to what is defining those rows. So wide data is probably quite useful for your sort of traditional data analysis in terms of in terms of that example where we had measures on different rows, so let's say at this data row. So wide data where you have the variables in their own columns is the easiest to work with and interpret. But then if your project is more complex and has these repeated measures and multiple hierarchies, this is where you would start thinking about storing that in long format rather than wide, and start using those units that are lower down to define your rows as opposed to using those higher up units. And then long format is sort of splitting these different hierarchies into separate relational data tables.